This is a short overview of NMR spectroscopy. NMR is nuclear magnetic resonance spectroscopy. And so why is nuclear magnetic resonance spectroscopy important? Well, first of all, it gives us a lot of structural info, which makes it very important for organic chemistry. We make small molecules in organic chemistry typically, and we need to confirm the structure. So suppose we made the compound at the far right by some method that we know about, and we're pretty confident in what we have. We can collect the NMR spectrum, that is the NMR data, the proton NMR data, and the proton NMR data will confirm that we've made that compound. So the hydrogens are color-coded. We can see which signals correspond to which hydrogens on this molecule. We're not going to go into the detail, but you'll understand the detail after this talk. Secondly, suppose we've made a compound or discovered a compound and we're not sure of its structure. Well, we could use proton NMR to gather hints about what the structure is. So we collect the spectrum again. This is the same spectrum, but just to show you how we might use it. We look at the signals. We identify what structural components those signals reflect. We put them together, and we get this structure as a proposed structure for this spectrum, and so we get good clues as to what the structure of a compound is. Thirdly, we can look at whether we have impurities in our sample in the proton NMR spectrum. So if we see other signals that are not part of what we expect for the product, those could be contaminants, and we can get an idea even of the proportion of contaminants in a sample. So NMR is hugely important for us.